Hello and welcome to a new In the Mail. As you can see, I have a bunch of items gathering up in my mail bin, so let's get started looking at them. Our first item is this LED power supply, a constant current one, but it's very strange because it's not the model I ordered and I can't seem to find it anywhere on the internet. So a couple of months ago I ordered a 30 watt constant current LED driver from Banggood, and it was supposed to look like this, and I'll add a photo when I edit this video. However, this is what I received. It looks completely different, and I've searched through Banggood and eBay, but I was unable to find any LED driver that looks like this one. Now the problem is I don't know its specifications. I could guess its maximum voltage should be below 50 volts because the output cap is rated for 50 volts, but that's about all I could tell just by looking at it. I could also connect a load resistor on its output and measure the maximum voltage, which I did, but I can't find its constant current output value. It's going to be tricky. The safest would be to start with an LED module or a string of single LEDs in series that would total about 40 volts of forward voltage drop and a current of about 900 milliamps. I think that would be a safe test to do with this driver, but that's another story to tell. There will be a link in the description for the driver that I actually wanted to get, which is a 30 watt one, 900 milliamps and 28 to 34 volts output. This here is our next item, a 64 LED light bulb. The LEDs are 2835 package, and this particular one is a warm white variant. I know what you're thinking. These are the cheapest LED light bulbs that you can get, and they're probably worst quality. And that's what I thought also initially. But I have another 3 of these with 50/50 LEDs, and I have been using them daily for the past 15 months, and they haven't failed so far. Sure, there might be a drop in light intensity over this 15-month period, but I think it's worth having an $8 powerful LED light bulb that's going to work at least 12 months. Now, the main reason I thought these are not going to last, it's of course the high temperature that they run at, because just this thin aluminum casing that they're using as a heatsink for the LEDs doesn't look like it could keep this thing cool. And sure enough, these bulbs run at over 60 degrees C in my ambient temperature of 28 degrees Celsius, which is quite a lot more than I would allow for these LEDs. However, even so, it seems they last and continue to work even after 15 months of daily usage. Let's also do a quick teardown of this bulb to check what kind of power supply they're using and how the LEDs are connected electrically and thermally to the heatsink. So we have these 4 screws on this side. Yeah, we have a pair of flimsy wires connecting to mains. This is, by the way, this socket, as you can see, can rotate about 180 degrees. So it will allow you to rotate this light so the beam does fall where you want it to fall. And inside it seems that we have the LED driver in here, and it's wrapped in some Kapton tape. Let me just get a pair of tweezers. So yeah, it seems that they wrapped this driver in some Kapton tape for isolation purposes. And I don't know, this is like maybe a 10 watt sized driver. Yeah, it could be. So I'm tempted to remove this Kapton tape and just check the design of this LED driver. Yeah, I think I'm just going to cut this remaining part. So it seems like our driver IC, it's the BP3125. We have a 400 volts 10 microfarads capacitor on the input, a diode bridge. This is our transformer. Yeah, this looks like a simple buck converter. We don't have any isolation between the primary and the secondary. So it looks like our driver IC is the BP3125, and I have pulled a data sheet for this IC, and sure enough it's a constant current LED driver with a maximum of 12 watts output power, and yeah, we pretty much see the typical application being implemented in this driver IC. We have the current control loop is using another winding on the primary, and as the IC detects the current increase in the primary winding, it adjusts accordingly, such as the current will fall in the secondary as well. So yeah, quite a simple circuit, but it's nice to see that they have implemented a constant current driver in here. And let's open this other side as well. So yeah, the LEDs are on their separate aluminum substrate PCB. This plastic cap comes off, and we see some of that white thermal compound, and we can see I can slightly move the LED board, so it's stuck with that thermal compound to this aluminum shell, which acts as a heatsink. But as I mentioned earlier, it's certainly not enough heatsink to keep these LEDs running cool. They run at about 65, close to 70 degrees Celsius here in my ambient of 28 degrees. And let's take a look at how these LEDs are connected. It seems like they are connected as 4 LEDs in parallel, and I don't know, probably 15 in series. Yeah, that could be the case. So they could run these at a very high voltage, making this converter much more small and efficient. So the idea here is that if you would like, you can get this board of LEDs out. You can get it, you can install it somewhere else on a bigger heatsink, and you've got yourself your own custom LED light. You can even use a different driver, but I think this one is good enough for this kind of application. So yeah, this is an $8 shipped 20 watts LED light bulb. Something I didn't mention earlier, this is not dimmable, and the output is supposed to be 1100 lumens. So a link for this will be in the description below. And our next item, once again some LEDs. In here I have 20 pieces 1 watt LEDs. 10 of them are the warm white variant and 10 are the cold white variant. The main reason for getting these was to change the cold white LED in my bedside reading lamp, because the blue tinted light is horrible for my eyes, and I do have that lamp here. Let me just show it to you. So as you can see, I'm pointing it at the camera, so it's a rather bluish light, and that is horrible for your eyes and for reading in general. So I think I'm going to go with this warm white model for the lamp, and I'll do a separate video on how I change the LED on the lamp. I also wanted to check out these LEDs. I kind of have this idea of building a custom ceiling LED lamp composed of a large heatsink with several small LEDs attached to it, and I haven't decided on what type of LEDs to use. From what I'm seeing on the internet, So far the 7030 LEDs from I believe LG seem to have a very good output, but I haven't played with those so far. I also seem to find an increasing number of these large PCB panel LED lights on AliExpress. They come in all sorts of sizes, and some of them have onboard integrated constant current high voltage drivers, so that might be a better option than building my own. Links for these LEDs will be in the description below. This here is an ICL 8038 signal generator kit. As the name implies, it is based on the ICL 8038 chip from Intersil. Let me just get the PCB out. And I have right here the first page of its datasheet. So this is the ICL 8038 from Intersil. As you can see, this is an obsolete chip, but still good and nice enough for kits like this. The chip itself does all the work, requiring very few external components. It's supposed to go up to 300 kHz, and it's capable of outputting square, sine, triangle and sawtooth signal. And just the other day I was playing with a DIY flyback converter. Basically I had a MOSFET, a transformer and the output diode plus capacitor arrangement. And I don't have a signal generator in the lab, and when playing with that flyback converter I really felt the need for one. And I was experimenting with my circuit and I wanted to try different frequencies as well as duty cycles. So I'll have to get a signal generator soon, but that's quite an expensive piece of gear. So until then I will assemble this kit in a separate video and see if it's any good for experiments like that. Our next item is this very small but interesting module. So let me just open this anti-static bag and show you the module. As you can see, it's like the tip of my thumb. It's a very small device, and it's called the OpenLog, and it basically is an SD card data logger. This thing supports SD cards up to 64 gigabytes, actually micro SD cards, because this is a micro SD card slot. And that's a lot of data logging if you think about it. 64 gigabytes worth of data logging. It's basically NetMega 328 programmed to record incoming serial stream to files on an SD card. So the original developer of this project is SparkFun, and they sell modules like this for $15. But the design files and the firmware are open source and can be found on their GitHub. Mine came from eBay, and it's interesting to have something like this handy because I had many times where I would have liked to log some data, but I didn't feel like messing with a fat library as well as writing entire routines for logging the actual data on an SD card. So this module just makes everything much easier. I can just push data over a serial port and it will record it to the SD card. That's nice and easy. Our next item is this very small, once again, module, and it's called a Super Mini 3 amp DC to DC converter. So yeah, you've heard well. These are Super Mini 3 amp converter modules. Because there is also just the mini version, but this one, the Super Mini, shaves another couple of millimeters from the overall size, and you can get these in packs of 5, 10 or even 20 pieces or more. And as you can see, they're very small. They just have a couple of input and a couple of output pins. They are very cheap and handy to keep around in the lab. They have an input voltage of around 5 to 23 volts, and the output is adjustable between 1 and 17 volts. Of course, the 3 amps advertised current is not the nominal rated one. That is just 1.8 amps. 3 amps, it's the peak current of this device, but you wouldn't want to run it at its maximum power because it will probably catch fire. The output ripple is supposed to be 30 millivolts peak to peak, no load, which is quite high. I would imagine under load conditions for example at 1 amp, that figure will get quite a bit higher. So these small converters, as mentioned earlier, they are handy to keep around in the lab for whenever you need to power a circuit, but you do need to be aware of their limitations and the fact that they are quite noisy. Next up, I have a couple of 10K 10-turn precision potentiometers. They are sold as Bourns, but I'm not sure I believe that. I think they even have markings. Yeah, so it says Bourns made in Mexico, but I'm not sure I believe that. Bourns make high quality potentiometers, and I don't think these are the ones, because you get these from China for $2.50, and probably the real thing costs more. But even so, as knockoffs, these are still good enough for some projects. So when compared to standard potentiometers, which give you, let's say, a 10 kilo ohm value over one turn, it's quite hard to get a fine adjustment. These 10 turn pots spread that resistance over 10 turns, so it's much easier to get a fine adjustment in a single potentiometer without implementing a two-pot solution, because sometimes you might be constrained by space on a front panel, for example. I intend to use these in a power supply project, and so far I have the transformer, I have the power supply electronics, the enclosure, but I am missing the display part. As soon as I receive that, there will be a video on building that linear power supply. So links for these pots will be in the description below. This here is a solder paste syringe, 10cc. It's the 6337 alloy, and this is the stuff used to solder SMD components to PCBs. If you haven't worked with solder paste before, it's basically liquid solder, as you can see right here in the syringe, in a paste form. And this is the stuff that gets applied with great precision over the required pads, so that when the heat is applied, they melt and make a solder joint. You are supposed to store solder paste cool, preferably in a fridge or a special cooler, to avoid degradation. And it does have a rather small shelf life, something like 6 months if stored properly. But for hobby use, we're not going to care about that. I will only use this to solder my hobby projects, so it's probably okay to store it at room temperature for a year and still get decent results. One thing they never send you with these syringes are a needle and a plunger. I can understand not sending a plunger because these things are usually used in semi-automatic pneumatic dispensing machines, and those have the plunger as part of the machine. You just need to insert the syringe, but a needle is not that expensive, and it would be useful to have one shipped with the syringe, just to make it easier to apply small dots of solder paste on your PCB. There are various brands and different leaded or no lead variants out there, and the price will vary according to that. This one is a Mechanic brand, and you will find a link for this in the description below. This here is a simple small metal spudger used to pry things apart, usually when taking things apart. I already have these two types of spudgers, and I keep them handy. Especially the plastic one is very nice because you don't leave scuff marks on whatever you are opening with them. But sometimes you need a thin metallic spudger, and I believe this one does the job. So let's open the package and check it out. So yeah, it's a very thin metal spudger that you can use to take things apart. It's kind of flexible, so that really helps getting in there when you want to pry a case open and unclip those plastic clips. It has this kind of soft silicone material glued, so that you have like a better grip. So yeah, it's quite a nice metal spudger. A link will be in the description below. Next up, we have this strange looking device. This is a bit extension tool that you can use with your electric screwdriver or drill. It's supposed to allow you to work around corners or tight spots where you can't actually fit the entire length of your screwdriver. It's just one of those tools that you see and you think, hey, it might be useful someday, so I'd better get one to keep in my toolbox. On one end you get this hexagonal bit that will go into your screwdriver, and on the other end you get the type of hexagonal receptacle that accepts screwdriver bits. The nice thing is that Banggood seems to be stocking more and more products in their EU warehouse, so shipping is fast within Europe. For example, this product arrived in 7 days. Prices on Banggood seem to be slightly higher than eBay, but often people will prefer to pay $1 more for an item that will arrive in 1 week instead of 4 to 6 weeks. In here I have another interesting gadget that will probably help me with shooting these videos. Let me just take it out of this box. It's quite a heavy item, so probably the shipping on this item is actually more expensive than the item itself. This thing, it's called a magic arm, and let me just show you how it works. It basically is an articulating arm that you can position in a variety of ways, such as to hold your camera or microphone or lights or anything for that matter. I didn't expect it to be this heavy, but it's very well built. It also comes with this clamp. I think you can use this clamp to secure the magic arm to something like a support bar, or maybe you can clamp it to the sides of a table as well. The arm has this, well, I would call this the main articulation, but you can also rotate the ends like this, so it's quite versatile, as you can see. And in here you have this these rotating pieces that will help you clamp various other objects. I must say, when doing video blogging, you need at least 2 or 3 of these mounts or similar ones, because you always need to position at least 2 lights surrounding the subject. Then you might want to position your camera above the workbench, and you might also have an external mic. So yeah, for sure this thing will come in handy when shooting videos. So as always, links for all the products shown in this video will be in the description below. I thank you for watching this video, and if you enjoyed it, please hit the like button below, and don't forget to subscribe, because that is a good way to receive notifications whenever I upload new videos like this one. See you next time.